All right, we're going to talk about graphing sine and cosine today, specifically amplitude changes, which are like our vertical stretch or compression, and vertical shifts, moving our shifting this graph up and down. So we're just going to talk about those two things, no horizontal shifts and no horizontal stretches or compressions, but we will talk about those next time. So what I brought in is probably the simplest unit circle chart I could find. That just has kind of our axes labels. So it's got our point 1, 0, 0, 1, negative 1, 0, and 0, negative 1, which is going to help us graph our parent function. Okay, so we're going to graph this really just between 0 and 2 pi, one full circle. So here is our parent function for sine. Y is equal to sine of x. And how we're going to kind of label this, we're going to go all the way out from here, which would of course be 0. And we're going to go out and give ourselves some space and go out, however far you bring your graph to 2 pi. And we are going to label this in radians. And we're going to split this up between 0 and 2 pi into 5 equal parts. And we do that by going halfway, okay, which would be pi, right? Half of 2 pi. And then we're going to go halfway between each of those. Okay, and we're just freehanding this, so it doesn't have to be perfect. Pi over 2, that's half of pi. And you can think of every one of these tick markers as being a half of pi, 1/2 pi, 2/2 pi, 3/2 pi, which is the same as our 270 degree angle right down here. It's like going 90 degrees. Okay, but the easiest way to do that is to go out to 2 pi, cut that in half, and then cut each of those remaining spaces in half. That gives you our nice 5 kind of equally spaced points. 1, 2, 3, 4, 5. Okay, and the reason we want those is because we're going to mark those nice values on our chart. And notice that sine, which remember is the y-coordinate value from our unit circle, has a maximum of +1. So the most we need to go up is +1, and the furthest down we're going to need to go, its minimum value is -1. Okay, so we're going to fill in all of our values in between. So we're going to start at 0 radians. And at 0 radians, my y-coordinate is 0. So we're right here at the origin. At pi over 2, or 90 degrees, my y value is +1, so we've reached our maximum. When I get over to pi, my y value is back down to 0. So the sine value is 0 at pi. At 3 pi over 2, my y value is -1. So we're at our minimum value. Try to get that at the right spot. And then when we get back to 2 pi, we've come full circle again, and we're back up to 0. Now I have an animation that will hopefully help show that the rest of these are not jagged lines. It's actually kind of a smooth curve to fill in a lot of these other points in between our unit circle. So we're graphing kind of the height of our point along the circle. And so you can see this kind of where the arrow is pointing, that it's graphing kind of the height from 0 there to our maximum of 1 and back down. So you'll see when it starts here, we're at 0, then it maximizes, goes down, back down to 0, our minimum, and then back up again. And we get kind of this smooth sine wave curve. Okay, so this kind of, we say, oscillates back and forth between 1 and -1. Okay, but that's our minimum and maximum value. So we do actually have a nice smooth curve. And one way of kind of remembering the difference between this and what we're going to do in cosine, they actually look very similar, is that you can think of graphing sine and cosine, it's like a day at the beach. Okay, so what I mean by that is we're going to talk about these different points as being like if you were at a beach. We're going to call the x-axis like our sand. Okay, and we'll say when we get to the maximum, this is like a cliff. The highest point. And down here, if I correctly made that look like the lowest point in my graph, we could say here you're, under the water. So when you're graphing sine in your day at the beach, you start in the sand. Sine, sand. Will help us memorize the difference as we go to graph cosine here in a second. Okay, but this is what it looks like. It does kind of continue going up, down every 90 degrees. We will either go from the sand or 0 to our cliff, +1, back down to the sand, underwater, back to the sand, and etc. We just kind of oscillate between those over and over again every 90 degrees in our parent function. For cosine, which is very similar, remember now we're going to be graphing the x value. So we're also going to go between 0 and 2 pi. So we'll come out here somewhere and mark 2 pi. We'll cut that in half, which will give us pi. And then half of each of those remaining differences, which is half of pi and 3/2 pi. Okay, so there's our 5 equally spaced points. But now we're graphing the x-coordinate of each of these values. So at 0 radians, the x-coordinate is 1. Oh, and don't forget, just like sine, cosine does have a maximum of 1 and a minimum of -1. Okay, so we're going to start, sorry about that, get out of here. We're going to start at +1. Okay, when we get to 90 degrees, pi over 2, the x value is 0. So cosine is 0 at pi over 2. When we get to pi, the x value, cosine, is -1. So we're down here at our minimum. At 3 pi over 2, the x value is 0. So we're back up here to, I guess, the sand. And then at 2 pi, when we come full circle again, we're back here, and the x value is back up at 1 again. And at first glance, this might almost appear to be like a V shape, but this, just like sine, also oscillates. Okay, so it's actually a smooth curve. And in fact, if you had kind of continued your sine wave over here, it's kind of like you're looking at a section between here and here on your sine wave. That's where our cosine value is. From here to here, it looks like that. It's kind of a shifted over sine graph. And in fact, they are kind of shifted over versions of each other. So cosine looks like this. Okay, so a couple important parts that we're going to label on here. The height from kind of the center of my sine wave, where the sand, quote unquote, is, to the cliff or to how far we have to go underwater, which is 1 unit in the parent function, is called the amplitude. Okay, so it's called the amplitude of our sine wave. Okay, that's also true for cosine. Okay, and the amplitude is always a positive value because we're talking about the distance kind of from the center of our sine or cosine waves to their maximum or minimum. Okay, now over here, we've also written kind of the functions we'll be able to modify today, and we can change the amplitude by changing A. So instead of A being a vertical stretch, which it technically is here, it's a vertical stretch or compression, but for sine and cosine waves, we call that the amplitude. And so that's one of the ways we will change this. And you can see, of course, for cosine down here, it's the same exact thing. Okay, changing K today is going to give us a vertical shift, just like K has all year when we talk about H and K. We won't directly talk about H when we talk about horizontal shifts later on, but we'll see a version of that. Okay, so this is technically the full sine wave where we can do other shifts. We'll talk about that in another video. And then we have a cosine version as well. So notice this is not directly H. Because we're going to also be doing horizontal compressions and stretches in this unit, so H is a little bit different. Okay, but K is our vertical shift, and that's basically just going to move the center of our graph, what we're calling the sand, or the middle of our graph, up or down. Okay, so here's our first example. Graph y equals 2 times the cosine of x. And this 2 is our amplitude. So instead of having a maximum value of, say, 1, this graph is going to go all the way up to 2 and all the way down to -2. So I'm kind of building my own scale here, but instead of maximizing at 1 or -1, it's going to go all the way up to 2 or -2. So it's just going to be taller than our original cosine graph. Now again, if you're sketching your own graph, we're going to go between 0 and 2 pi. We'll go in the middle of that and write pi, and then do half of each of those, pi over 2 and 3 pi over 2. Okay, these are the nice values to graph by hand from the unit circle. So cosine, remember cosine, which I didn't talk about back here in our day at the beach, cosine starts on the cliff. So cosine, cliff. And then you head to the sand. You start on the cliff, you walk on down to the sand, then you go underwater, back to the sand, and back up on your cliff. So just to help you remind where sine and cosine graphs would normally start, sine starts in the sand, so in the middle, and then you head up to the cliff. Cosine starts on the cliff, and then you head to the sand. Okay, so we're graphing cosine in example 1, so we need to start on our cliff. Just this time our cliff is a little bit taller. We're up here at 2. Then we head to the sand, which would be back down here. Then we take a dip underwater, which would be at our minimum value -2, back to the sand, and back up to the cliff. Okay, so here we have a graph with an amplitude of 2. There was no vertical shift or anything else. I saved you the pain of watching me try to draw that smoothly in. But there's our graph. Okay, in our next example, we are graphing 1/2 sine of x. So again, we have an amplitude change here of 1/2. So rather than going all the way up to 1 and down to -1, we are only going to go to -1/2, or 0.5, and positive 0.5. So this is going to be shorter than our normal graph. We have a kind of a vertical compression here. So once again, filling in these values between 0 and 2 pi. We mark the middle as pi. Between that, pi over 2, and this as 3 pi over 2. Okay, there's our 5 equally spaced points. And remember that sine starts in the sand. Sine starts in the sand. So we start in the middle here, and then we head to the cliff. So think of cosine heads towards sine, cliff to the sand, and sine heads towards cosine to the cliff. So that helps you remember you go up. So for graphing 1/2 of sine, we would go up to our maximum here on our cliff, which is now only 0.5. I would like to sometimes give myself a little dashed line to remind myself, kind of stay between the lines. Okay, so there's our maximum value. Our back down to the sand at pi, we're underwater at 3 pi over 2, and then back to the sand. Okay, so we get a graph that looks something like this. All right, our next 2 examples, we're going to step up the intensity a little bit here. So we do have an amplitude change of 1/4. So we're only going to go up and down 1/4. We also have a vertical shift this time. So we're shifting our graph up 3. So notice I've already started with a more vertical graph here. So rather than the sand being at kind of y equals 0, where the x-axis is, that middle of my graph is going to be up at +3. So we're going to go up 1, 2, maybe I'll space these out a little more. 1, 2, 2, and 3. Maybe that was too much. All right, there we go. Sorry about that. Let's say that's +3 up there. Okay, so that is going to be kind of the middle of my graph. We're going to think of that as like our new x-axis, essentially. Right? Our whole graph has been shifted up 3. Okay, so we're going to pretend that's my x-axis, and then we're going to be able to go up or down 1/4 of a unit from there, so not very high. So let's say that's maybe 1/4. So I'm even going to put some more dashed lines to remind myself to stay between the lines. It's like when you're a little kid and you're first learning to write your letters, right? You have these nice lines. Okay, so it kind of tells me where my maximum and minimum should be, up or down 1/4 from 3, and that 3 is kind of the center of my graph. Now we're graphing sine. I still need my equally spaced points here, so we're going to say, 2 pi. Halfway will be pi. And between those would be pi over 2 and 3 pi over 2. And of course, at the origin, 0. So sine starts in the sand. So sine will start at 0. So there's 0. And then it's going to go to the cliff, my maximum value. So at pi over 2, right, it's going to be at the highest point, up at 3 1/4. Back at pi, we're back down to the sand again. So in the middle of my graph at 3. At 3 pi over 2, we're at our minimum, 2.75, down 1/4 from 3. And then at 2 pi, we are back in the sand. So connecting those with our nice smooth curves, we get a graph that looks something like that. Here, our last one, we're going to add in an extra complication. We have not talked about what happens when I have a negative a value, when we flip that upside. Okay, so if our amplitude is negative, just like our other negative a's throughout the year, it's going to flip my graph upside down. So you can think of that as reflecting over the x-axis if you want, right? We talked about that's not always necessarily true because our vertex might change, but it's going to flip our graph upside down. and we have an amplitude of 3. So we're going to be going up and down 3 units from our center. And because of our vertical shift, the center has changed. It's moved down 2, right, for that -2. So the first thing I like to do in my order is I like to go find my new center if there is a vertical shift. So we're going to go down 1. Oh, maybe we'll make that a little closer. 1, 2. We're going to go down 2. Okay, so this is kind of the new center of my graph. It goes across here. Okay, and then remember from my amplitude, we're going to go up or down 3 units from my new center. So 1, 2, 3. This would be the maximum up here. So there's my lines and some labels as well, and we can go down 3 units. So the lowest we can go, it looks like, would be -5, will be our minimum value. Okay, so we are graphing cosine this time, which does start on the cliff. So cosine starts at the cliff, meaning it starts at our maximum. Oops, I'm trying to get ahead of myself. We haven't labeled all the way out to 2 pi, right? So let's do that on our axes. 2 pi from 0, so halfway between is pi, pi over 2, and 3 pi over 2. There we go, now we have our labels. So cosine starts on the cliff, we'd be up here at our maximum value. However, for this graph, we're not technically going to start on the cliff. Well, we will. I guess we'll start on the cliff. We'll do the reflection afterwards here. Let's graph what the original would be, and then we're going to do our reflection. Okay, and the reflection is over the center, -2. So let's first just graph what regular cosine would be. So we'd start on the cliff. We'd go down to the sand, then we go underwater, back to the sand, and back up on the cliff. So I'm going to do this with a dashed curve because this is not our final graph. We have not done the reflection. So this is what cosine shifted down to and stretched by a factor of 3, or an amplitude of 3 would look like. But remember that my graph is flipped upside down. It's a negative a value. So all we're going to do is take where we're underwater, this minimum, and put it up here at the maximum. Anything that was at the maximum will become at the minimum. So here and here end up both coming down to the minimum. And things that are in the sand, well, if that is the line of reflection, so this is kind of the line we're reflecting our graph over, they stay put. And so my upside down cosine graph should look something like this. It's reflected upside down. It's stretched by a factor of 3. And it's been shifted down 2. So again, as you go through examples, and of course we'll do more in class, shift down 2, make that your center. Go up and down your amplitude, which in this case was 3. And then if you have a reflection, I like to do those last.